Hello everyone, this video is talk about Homework 3's Problem 1. So we can see the first question is asked we to find if we have the probability as px equals to k equals to bk p to the power of k minus 1, where p is integers from 1 to infinity, and p is between 0 and 1. So first is find what the b is to represent px equals to k is the probability mass function. We know that if we want to make p as a probability mass function, we should follow that the sum from 0 to infinity of p, which is the range of k, equals to x equals to k. Here we should be 1, and that makes the sum of p equals to infinity of b k p k minus 1, which equals to b is a constant of the sum, so we can put them together as minus 0 to the infinite k p k minus 1 to the power of k minus 1. So now our goal is to find what's the result of this summation. So basically it looks like a kind of geometric series. So we know that the sum of the geometric series from k equals to 0 to infinite of pk is equals to 1 minus p equals to 1. Then if we get the derivative of each side, we can have the summation of k to the 0, k equals to 0 to the 1 of k p to the power of k minus 1 equals to 1 to the 1 over the 1 minus p to the power of 2. And now we substitute this result here as b times 1 over 1 minus p to the power of 2 equals to 1. Then b is equal to 1 minus p to the power of 2 squared. Okay, for the second question, we are finding the result of the expected value of b. So we know that it is equal to summation from the range to the case range, the summation of k times p to the power of x equals to k. Here is equals to the expected value of k of x. So now our goal is to find the result of this summation. We substitute p here as k equals to b to the k to the power p k minus 1, which is k equals to 0 and k squared times 1 minus p square. No, is we didn't consider b together now is k square b. We can put b outside, so it's b summation k to 0 and k squared times p k minus 1. So to find this, so now our goal is to find this result since we already know that b is equal to 1 minus p squared. So as we already found before is that k, the summation of k, p k minus 1 equals to 1 minus p to 1 over 1 minus p squared. So if we take now we times p to both sides, which is k, p is to the power of k is equals to p over 1 minus p squared. And then we got the derivative of p, which is the summation of k squared p k minus 1 equals to 1 plus p to the over 1 minus p's third to the power of 3. And then we substitute this the b here. We times b to both sides, which is 1 minus p squared, 1 plus p, and 1 minus p to the power of 3, which is 1 plus p, 1 minus p. For third, we are need to find the expected value of x squared. So which means we are finding the range of k, which is k squared times p of when x equals to k. And this one, if we replace when we substitute the values here to the p, we have which is equals to b, k equals to 0, and k to the power 3, p k minus 1. So we already know b as well, and then we need to find the value of k squared. As we used in the previous problem, we know that the power of k squared p k minus 1 is equals to 1 plus p over 1 minus p to the power of 3. Then we times p together and get the we times p at the both sides and then got the differentiation. It is equals to p squared plus 4p plus 1 and then over 1 minus p is 4. And then we times b on both times b as both sides, which here is equals to x to the expected value of x squared. So it is p squared plus 4p plus 1, and then over 1 minus p squared. And first, we had to find px squared minus the expected value of x squared. So we just need to substitute the both what we have in part C and what we have in part 2, and the results and find the square of the result, which we will have 2p over 1 minus p squared. And for the fifth, and for the part E, if we have p equals to 1 over 3, and then we can have a hidden condition as b equals to 1 minus 1 to the 3, 1 over 3 equals to 4 over 9. And now we are finding the conditional probability that x equals to k, given by x is in 2 to 5. It is equals to the intersection of x equals to k and x is in 2 to 5, and then the summation from 2 to 5 with the replacement p. And now we have the result as the summation from 2 to 4, 2, 3, 4, 5 substitute into the k, which is 0.5377 to 1, and then times, we cannot find the expected result, but we can replace it into the formula as 409k 1/3 k minus 1, where k equals to 2, 2, 3, 4, 5, since it's decreted, and also equals to 0 for otherwise.